My name is Alex, and I welcome you to the first video in a series documenting the development of this little game that I've thought about making for quite some time. The video will be documenting the entire development process from start to finish, from the design phase, all of the requirements and architecture, implementation, and everything, hopefully. At the same time, decided to document this whole process. If some of you find it interesting or useful in any way, that, of course, will make me happy. Anyway, without further ado, let's dive into it. First video is going to be more about the requirements and the design, what the game is about, and what are the tools and platforms I'm going to be using in order to build this on, and we'll go from there. So first, the project. The project is a game, as I mentioned. I know, very original. It's a simple game, turn-based strategy game, online, with some community building aspects to it, and not requiring too much in terms of hardware and software on the users. Browser-based, so no installation or anything. That's the basic idea. And this is just a little passion project that I thought of quite some time ago, a few years now, and never had the chance to find the time to commit to it. And this time is now, so it's going to be quite a learning experience too for me personally. So we'll see if it goes anywhere, and if it does, how far. So the game itself is not going to be anything complicated. The graphics is going to be 2D. Well, I guess more what they call them 2.5D with the isometric projection board. And but the graphics themselves are not just going to be sprite-based 2D graphics. And the idea is that the mechanics are quite simple, as we'll see further in this video. But the idea is to have the users kind of engaged, and it's not like chess with perfect information game. There's luck involved, and there's potential for comebacks from dire situations on pure luck, which is I find exciting. But at the same time, there is some strategic elements and some even psychological elements where you could analyze would be able to analyze somewhat the patterns and player moves, the opponent's moves, and see if you can predict the moves and win the game that way. So once again, it's just a passion project. There's nothing, there's no sponsors or anything like that. There's no goal in making any money off of it or anything like that. It's just going to be a pure. So yeah, there are no plans for any in-game purchases or any kind of microtransactions or any kind of monetization to begin with. The idea is to build something fun for the community and see where it goes from there. The intention now is to publish the source code to a public repository as an open source, and that's about it. So let's talk about the features of the game, and later about the setup, the whole mechanics and things like that, and what is the development plan. So the main game mode is going to be player versus player. This is an online game first, and the two modes, I thought maybe all of this is in flux. This is just the plan for now, and of course things may change. But the main idea is to have one-on-one battles where you just take on one single opponent, StarCraft ladder style kind of. But I think the most fun mode is going to be the 3 players versus 3 players, where the team play opens up a little bit more interesting scenarios where instead of just worrying about your own health, the win for the team is more important. It opens up some more scenarios in my head, at least. We'll see if it actually works out the way I see it. Anyway, And there will be one additional mode where you could play against the bots in a 2v2 setting, where one human player will have 2 AI opponents and 1 AI ally. And this is primarily this mode will most likely serve as a kind of tutorial or training before the PvP. The main focus is PvP. The plan is to have a ranked ladder for registered users, where they can simply think StarCraft 2 style. You could queue up for a random game 1v1 or 3v3, or create a lobby for a game and invite friends or other random players to participate. So the game will also be available for unregistered users. So you just log in on the website in a browser and can start playing immediately without having to create an account or anything like that. In that mode, the rank ladder will not be available because, of course, you need to attach all of the stats to an account. And if you play without an account, you can still queue up for random matches, unranked. You will still have access to all of the features inside the game, except the ranking. All right, now let's talk about the game mechanics. This is not how the game is going to look. Even the character itself, I made this one just for show for now, as a placeholder. It might change anytime. All right, so as mentioned before, this is a turn-based strategy game. And the way it will work is that each turn will have a set timer, very short one. The game itself is going to be pretty fast-paced, requiring quick action decision-making. Each turn will last for 10 seconds. Where the timer will start counting down immediately, and within that time frame, the players have to make decisions about their moves. So each player will control one character. So within the time frame of these 10-second terms, the player has to decide which moves to make with the character, and the number of moves is determined by the action points. There you have 2 per turn, and then each character has 3 points of health. Which allows the player to survive actually 2 hits and then die on the third one. One action point corresponds to either one move on the board, which is a move to a neighboring cell, or it could be used to move over 2 cells, and then it will cost 2 action points. Once action points are exhausted, there are no more actions that the player can perform. So you can either move 1 cell and then perform a shooting action, or you can move over 2 cells and then not do anything after that for this turn. Similarly, for each shooting action, for each firing of this cute cartoony missile, 1 action point is used to fire that rocket to any place on the board, to any cell on the board, to target any cell on the board. And if you're not expended any action points on moving, you can actually shoot 2 of these rockets while standing in place. All right, that's the main mechanic. And players have to make decisions about how to spend their action points for each turn during this 10-second time frame. After the timer runs out, the game will perform those actions simultaneously for all players. Like this, for example. A move is made, the rocket is shot, and as you can see, when the rocket hits the player loses 1 action point. And the goal of the game is to not get hit, of course, is to see if you can avoid the rockets while targeting predict the cells where the opponent will move and target them with your rockets. All right, the 2v2 setting for the AI will have 2 teams opposing each other on each side of the board, and the 3v3 matches will have 3 players like this. And as you can see, the idea is that with team play, it opens up opportunities to think, to strategize a little bit more, and to kind of quickly assess the patterns in opponents' moves after a few turns and see how well you can predict the opponent's movements and target the cells where they move, as opposed to try and beat the patterns that the opponent is making about you in their head. So very, very simple setup, but I think it might open up some interesting scenarios. And then there's, of course, will be some kind of limiter on the number of terms, as in after a certain number of terms, if because you could avoid this being hit for a while. So the way the mechanic is going to, so the mechanic I'm thinking of implementing is going to make progressively, after a certain amount of turns, progressively lock some cells from moving, and therefore restricting the field of movement for players, and therefore making it harder to avoid being hit. And this will ultimately speed up the outcome of the game. So that's the gist of it, the gist of the mechanics itself. So now let's talk about the requirements for building this. As mentioned before, the idea is to build it, make it work in a browser. The graphics for the game would like to have something a little bit more sophisticated than just regular HTML graphics. And here the graphics engine will leverage WebGL. This is going to be planned to be as a free game, accessible to everybody, even without having to create any kind of user account or anything. Just go into your browser, go to the website, and start playing. And as mentioned before, the source code for it will be published in a public repository accessible to everybody. Since there's no plan for any kind of monetization things, and I'm not discounting them, but there are no active plans for that, I would say. Of course, that puts a lot of restrictions on the type of resources that could be used, especially when it comes to proprietary resources. But in general, the idea is to have this, because the project itself is open source, is to leverage as much as possible open source platforms and tools in the development of this project. So therefore, proprietary engines like Unity or Unreal are not feasible for this. But even Godot, like open source, I was thinking, actually, I don't even know if Godot would work in this kind of scenario, because I've never worked with it, don't have any experience with it, haven't really looked into it. Well, in any case, I'm not going to be using any of these well-established big game development engines. And another reason is that I would really like to code a lot of these stuff on a lower level and have more control over the development rather than these high-level abstractions. So on the back end, the code itself may be compiled for different platforms, but right now the plan is to do everything on Windows. As you will see, the majority of the code do everything on Windows. Data storage and management will be done using the SQL server in the cloud, as well as server-side local storage will be managed by just simple SQLite databases. And I'll explain the decision for that later on when we talk about the architecture. And on the front end, it's pretty much going to be like a website, and therefore the normal front-end web development stuff is in play. So of course, HTML and JavaScript and style sheet, cascading style sheet, and the frameworks that it comes with, like Bootstrap and things like that. All of that is in play. As long as, primarily, I'm not restricting myself from any proprietary components. However, I would really like to leverage as much as possible free and open source libraries. And there'll be, of course, a lot of custom code for this. On the front end, the game itself, the game engine, I would say, is most of it is going to be implemented with WebAssembly. So now let's talk about now that we have the requirements, let's talk about the development stack. And we'll separate that into code, graphic, and APIs, things like that. So we'll start with code. So the main development platform framework for this project is .NET Core. And the current version, as of now, released by Microsoft, is version 9, and that is what we are starting with. Of course, if the development takes some time and the maintenance, the updates, we might update it to future versions, but that is not the discussion for now. For the web application front end, it will be leveraging Blazor.net, which is part of the ASP.NET infrastructure, very robust and already kind of sort of newer, but at the same time quite mature. It's been a few years now in development, and I enjoy building Blazor applications quite a bit. We will be using mostly static or server-side rendering for the the website and everything around the game itself, but the game screen itself will be using a WebAssembly frame. All right. And for the communications, for the networking part, for data transfer and all this stuff, that is also ASP.NET has a very nice abstraction for Web API, which is sits on the REST APIs. And that's what we'll be using. It saves a lot of time, actually. And the data management, another thing that is I particularly find really nice with .NET is the entity framework that allows, for some of you who might not know what it is, it's just a really comprehensive and nice abstraction of persistent data storage and management. And we'll be using that. So that's another reason why the documentation, like documenting this series, might be useful for people, because if you're looking at some guides and tutorials on coding on YouTube, it's usually tied into some certain component or certain framework, or maybe certain even aspect or pattern. But here the idea is to have like a full series of stuff for the entire project, kind of specialized in a way, niche in a way. But at the same time, there's a lot of these technologies that are used outside of game development, things like that. And we'll be diving into many of them, and maybe some people find it interesting how Entity Framework, for example, is used in a project like this, or how Web API is built within this context, and could be built for and could be extended for other projects that have nothing to do with building games and things like that. So these series are about more of a collection, a stack of different development approaches and tools and frameworks, and how they fit together, as opposed to just focusing on one. And of course, I may make any excuses for why I choose this specific stack, but the main reason, if I'm being honest, is the language. The C# is something that I've worked with for over 20 years now. I've worked with many different languages and environments, and so far, C# I personally, I guess it's a personal preference, I find the most comfortable. I can't find a better word. It's the way the software is engineered, the way I engineer software in my head. I find doing it with .NET and C# is the most convenient way. But again, that's just me. I'm not saying that that's how it is. That is my experience. And that's why, again, like the WebAssembly, the same thing. There really is if I'm being honest, it's hard to find a good justifiable reason for WebAssembly at this point. So the promise of WebAssembly is speed, pretty much. It's saying, hey, we have this natively compiled code that runs inside your browser client side, and supposedly it's so much faster than JavaScript, right? That's the main selling point, at least the one that I heard. And to be honest, like I don't see that Wasm being that much faster than JavaScript. That says a lot about how well the JavaScript interpreters are developed in browsers, in modern browsers. It's amazing, the optimizations and there are a lot of smart people working on that, and it really shows that JavaScript is pretty fast. I mean, the computers are fast, but apart from that, it does the job. So WebAssembly, I guess another thing is it's a little bit less open, so that's why bigger companies might, bigger projects and enterprise solutions might pursue that on the client side. But for me personally, the reason I choose Wasm over JavaScript is C#. That is the main reason for me personally. Architecturally, all of the neat things, all of the frameworks, and all of the patterns, like your dependency injection and services and whatever else, compiles to Wasm and works on the client side. And to me, building architecture is a lot more convenient than JavaScript. Though I'm not a JavaScript hater. It's a matter of preference. I know there are a lot of people who hate JavaScript with a passion, and I can even understand the reason why someone would hate it with a passion. I'm not like that. I'm not even disliking JavaScript. It's just a matter of preference. I think building applications with .NET and C# is a lot more solid in terms of architectural consistency. For me, it's a preference, again. So that being said, of course, because Wasm does not have access to the HTML document, of course, it was never designed to be a replacement. People say it's a replacement for JavaScript. No, it's not. It's really an augmentation to JavaScript, I would say. We cannot avoid JavaScript in web development at this point, no matter what we do. So there will be some JavaScript there, and then not a lot though on our end. There will be a lot of JavaScript code running in the application, but most of it is not written. I'm not going to write most of it. It's in the libraries, and as you will see later. And then the regular stuff, we have our HTML inside our Razor components. That Blazor used very nice, I would say, blend of HTML and C#. I really enjoy working with the Blazor front end. We have our cascading style sheets, frameworks. Of course, Bootstrap, I guess, is the most straightforward and widely used. So we'll go with that for the most part and write some of our custom styles and things like that. Very basic stuff. Of course, JSON for data, for data serialization in some places. All right. Now another thing I want to avoid is AI-generated code, which is, again, I'm not an AI hater or anything like that. But the idea is to really build the code by hand, because what AI, like in my experience using AI for coding specifically, it is really good if you start building something in a platform that you have little experience with. Say, for example, you're picking up a new framework, you're picking up a new language, you're picking up a new environment or a new whatever library. Then at that stage, asking AI to generate some piece of code for you can teach you a lot about how that particular framework or language or library is used. That is very useful. But here, since I'm leveraging most of the frameworks and platforms and languages, at least, that I will be using for this project, as I have pretty good experience with, I find asking AI to do things it's not the style in which it generates code for this is not consistent with how I have my style developed over the years in this, and this way this clash does not really sit that well. Even though, again, I'm not against it, we can use AI to ask questions about certain things. It's certainly a useful thing. But me personally, again, StackOverflow.com is the most valuable resource for a developer, and that is, if you're a developer, I am 99.9% sure you agree with me on that one. All right, so that's the code. Now let's talk about how we approach the graphics. And the graphics that we have, the first library that we're going to be using and the most leverage library is something called Pixie.js. That's a JavaScript library wrapper for a 2D graphics using WebGL. It's an incredible project. I don't really have that much experience with it. I've discovered it recently, but just working with it a little bit and reading and learning about it, it really resonated with me the way that project is being developed, the way that they prioritize freedom for developers and prioritize speed of graphics pipeline over convenience of having certain patterns and pathways in how other graphics engines do it. I find this very refreshing. I really like the way it is set up. So that is what we will be using. I highly recommend looking into them if you are interested in learning about graphics, browser-based GPU rendered graphics. Then, because it's a JavaScript library, and once again, I don't have anything against JavaScript, but we need to, because the majority of the engine itself, the client-side running engine is WebAssembly, we need to connect the JavaScript graphics renderer to our engine somehow. And of course, the .NET, ASP.NET, and Blazor.NET, they provide a very nice interoperability component between the WebAssembly and JavaScript. That in itself could have been enough, but I looked up if anybody had already looked into making an abstraction library for Pixie.js in Blazor. And lo and behold, I found an open source project by the developer SpawnDev. Besides wrapping Pixie.js, he has other things. I also strongly recommend looking him up on GitHub. By the way, there will be a lot of links in the description for all of this. You can just go in and browse all of these resources. Going back to Pixie.js, what SpawnDev did, he wrapped the Pixie.js functionality with the Blazor JavaScript interop. Actually, the library that he used for interoperability is he himself written as a different library, specifically more general JavaScript interop library, which is very, very impressive in and of itself. And so we will be using that. However, again, it looks like, as great as it is, it looks like the Blazor.js, Pixie.js component, a library, I would say, is wrapper is still in development, or is maybe, I'm not sure, maybe it could have been abandoned. It has the majority of the stuff that we need, but that's the beauty of open source, is that both Pixie.js is JavaScript open source, and SpawnDev's code is open source. We can easily extend and augment the stuff that we need for us, and that's what we will be doing as well, because some of the functionality in the wrapper is missing that we need, and that's not a problem, because writing it from scratch would have taken a lot longer than starting with the incomplete library. Anyway, that's as far as coding is concerned. Now, but besides coding, we actually need to do some graphics design, right? And again, I am no graphics designer. However, I do have some experience with it, both 2D and 3D. And I have more experience with actually 3D graphics using Blender, which is another great open source project for 3D design. Well, not only 3D, it's actually, you can do 2D in it as well. It's a really comprehensive utility tool, app, whatever you want to call it, and it is free. It is free to use, and I've been using Blender for a while, actually, for some other things, professionally and non-professionally. It's pretty good. A lot of stuff we'll be doing with Blender. Even though it's a 2D graphics, you can do 3D pre-rendered graphics. That's what I'm talking about. Inkscape is a nice tool, again, free tool, link in the description, that it can be used to work with vector graphics. And there's also Photoshop, and that one definitely is not open source, definitely not free. But actually, I have a license from 2002, Photoshop 7.0. And interestingly, it still works quite well on modern computers. You can just install and use it. And that's what I will be using, has most of the stuff we'll need for this anyway. Another tool that we'll be using a little bit is the texture packer by Code and Web. It's a free tool to generate sprite sheets where you have, say, multiple images and you want to generate them, you want to put them all in one image file to be consumed by your engine. That is a nice tool. That it's not completely free, so there's a free version and there's enough functionality in the free version for us to leverage, but there are other nice features that it has in the paid version as well. As I said, we're not going to be using any AI tools for coding. For graphics, actually, because I really suck at drawing, there are a few things when it comes to 2D graphics that we will use a basic AI assistant. And it's, I have this Samsung Galaxy tablet that has a built-in app for generating AI images from sketches. And in fact, that little critter that you saw in the beginning of the video is generated with that AI assistant. So not a lot, just a few things that I am myself not capable of. And once again, I would really love to support a human artist to do things like that. However, I just, as considering the circumstances right now and the fact that this is not a commercial project or anything like that, I just don't have the resources to do that. All right. So the next part of the development stack is the IDE that we'll be using. Once again, I have worked with many IDEs over the years, and in my experience, nothing beats Visual Studio. Like, not even close. I've done some Android development. I've done some Java development with all of these things like NetBeans and Eclipse and things like that. I haven't done any Rust development, so I don't know. It might be something better, but from what I have in my experience now, Visual Studio is perfect. It's also, the community edition is free. As you know, it is integrated really well with the Microsoft infrastructure, which the .NET Core is part of it. And outside of Visual Studio, the text editor I really like is, of course, very widely used and loved, the Visual Studio Code. Even though, again, we're not going to be running anything. I know we can set up VS Code as the IDE itself, and many people prefer that to Visual Studio. But I'm old school in that regard. All right, and for source control, it's going to be Git with the GitHub repository. As the series progress, I will be adding code for every video I make or off-screen. Whatever code I write in this project will be committed regularly to this GitHub repository. And in this video, we will actually, the first thing we'll do is we're going to set up the repo. I will provide the link to the repo in the description where you can look at it, clone it, whatever, fork it if you need to. And we'll gradually be building on it. So today is May 14th, 2025, and if you're viewing this video in the future, you might already have all of the code developed in that repo, or the repo might not exist. I don't know. No one can predict the future. All right, so now as we've looked at the development, now let's look at a little bit of the architecture. And this will be the last slide in this presentation, and after that we will go into Visual Studio and we'll make a solution for it and start populating the folders with projects, and of course pushing it to GitHub. And that's going to be the purpose of this video, like the end. Okay. The architecture I will again immediately divide into two parts. One is that the frameworks, libraries, and tools we'll be using out of the box. I will not list all of them, but the majority of it. And this is again only for the coding. The graphics design is a separate stack. We'll dive into it in later videos. But this series is about software development first, and everything else is in addition to it. So out of the box, we will have some server infrastructure provided by Microsoft. And so out of the box, we'll have the backend infrastructure sitting on top of the Microsoft ecosystem. I said, and the server, I have not completely, none of this is set in stone. Any of this can change. Most of it, some of it will change, most of it won't, I predict, but I don't know. But as of now, the server is planned as this is going to be either the Kestrel, pretty straightforward, simple server, or we could use the IIS, the older kind of Microsoft web server that is not that widely used, I find, but I've done a few projects with it. I'm quite comfortable with it. And again, I've encountered a lot of hate to it, especially from Apache users. But I don't really find it that frustrating to work with IIS. I don't know. It stands for Internet Information Services, for those who don't know. And then on the back end, we'll have the SQL Server, the Microsoft SQL Server for persistent data storage. And the idea is to host all of this in the cloud somewhere, most likely with AWS, the Amazon Web Services. And they have nice, they have nice support for everything, pretty much. I work with AWS a lot and don't have much complaints about them. Yeah, so for the data, the RDS service, they have the relational database service is quite nice, where you don't have to worry about, keeping individual server instances up and all. It's just the virtualized SQL server that you get access to immediately. Anyway. So, and then on the software side, we have the libraries and frameworks that we'll be using. We'll repeat some of it here. We have the main framework is the .NET with all of the nice technologies that come with it, with the Blazor server-side rendering and WebAssembly, with the ASP.NET Web API abstractions, and with the ASP.NET Web API infrastructure and abstractions, and the EF Core entity framework for data abstractions. Saves a lot of time. For the front end side, is the main library is, as mentioned, Pixie.js for graphics rendering. That's the most specialized, I would say, library specifically for 2D graphics that we'll be using, wrapped by the beautiful Pixie.js Blazor wrapper by SpawnDev. One thing I actually didn't mention here, I forgot, is that we'll also, for Bootstrap, we will be using the Blazor Bootstrap wrapper. Link in the description. That allows it's a library of Blazor components that wrap the styles, all of the CSS classes from Bootstrap. Really makes it much easier to implement with Blazor. It's just, I wouldn't say easier, but better, architecturally better suited for that, and faster, definitely faster. And then SQLite, once again, put here in libraries and frameworks, not on the hardware side, because this is, I realized we'll need to be using some local data storage outside of the SQL Server, because SQL Server will be sitting on the RDS, in an RDS database, which is a separate instance from the actual physical server or whatever virtual server that we're running on. And there is, the database and the server communicate through network protocols. That, of course, implies some latency. But for some of the data, I would like the server to have direct immediate access to, and therefore it makes sense to have some of the databases sitting directly on the server instance, on the file system of the server instance, and have the server process pick up, write and read data directly off of the file system of the same server with no network a lag or anything like that. And SQLite is a great library to do that. It does not require much setup in terms of how you create and manage your database, but at the same time abstracts all of the concurrent access to the database file and everything quite neatly. And we'll be using that for some stuff in our architecture. Actually, I will explain it in this slide later on. Now, this is the out-of-the-box stuff, and let's talk about what we will be building, what I will be building, we will be building together with you, with all of you, hopefully, who find this interesting. We'll build the code that we will build ourselves. And it's going to be a kind of layered architecture where we will start with a more abstract and more general infrastructure based on the out-of-the-box tools and gradually shape it into a special set of classes and services that more closely align to the requirements. And we'll go in a couple of layers. And so, for example, Pixie.js is a generalized graphics library. It could be used for anything. It's not specifically for games or for this particular game. So we'll have some kind of engine that will abstract some of the functionality and wrap the Pixie.js code into a set of classes that will be less general and more specific to the games. So that is the JScene component, which is, I guess you could call it a middleware engine for these applications. The components I'm thinking is going to mostly work with the. It is a WebAssembly component or rather C# component compiled to WebAssembly that will communicate mostly with Pixie.js and wrap it, or SpawnDev's Pixie.js wrapper, and create still an abstraction, but a more specific abstractions to a more general abstractions from Pixie.js. So we'll be building a scene tree specific to our game. We'll be animating we'll be abstracting some animation functionality, because none of the stuff is available out of the box from Pixie.js. The asset management, even though the Pixie.js has its own asset manager, we want something that is more specific to the types of assets that we will be using in our game, in our project. Things like a particle system, for example. It will be a purely WASM-based logical component to generate particles that will call into Pixie.js to actually generate render graphics for these particle systems. So things like that. There will be some Pixie.js extensions, and that's mostly the stuff that is missing from the SpawnDev's library. And we will be doing some JavaScript interop, because there is a bottleneck that as great as the WASM wrapper for Pixie.js is, and it's not something that SpawnDev did wrong, it's just the way the interop is done between WASM and JavaScript in Blazor with the JSON serialization that creates a serious bottleneck in working with graphics-heavy libraries like Pixie.js, because you would need to supply a lot of input for Pixie.js to render graphics, or for every sprite. Say you could have thousands of sprites on your screen, and all of the information about the position and transformations and scale, all of that has to be communicated. If you're processing this on the WASM side, you have to communicate that to Pixie.js, to JavaScript, and that is done through JS interop, and that is for this particular purpose is slow. It's not feasible to use it like that. So, but no worries. I've actually looked into that, and I will dedicate an entire video to this little component inside the engine, and that overcomes, for the most part, I would say works around this bottleneck, and it's an interesting one, related to, not going to give it away right now, but it's related to JSON serialization and how we can skip that, for the most part, to push data from WASM to JavaScript much faster. And this again, it's even though this is what I'm talking about, even though it's part of this project, that video in itself may be useful for any number of other projects for people. So documenting it makes perfect sense. And finally, we'll have some dependency injection services that we will be including in our scene engine, because we will need to consume the structures from classes from the JSON engine in the higher levels, and a lot of it will be done very nicely. It's with dependency injection. Outside of the JSON engine, we will have a network component that is also abstracting the connection between the data storage, the clients and the API, the server, the clients and the API. And that is mostly related to, it's kind of like the domain level component library that will have the definitions for the data models that we'll be using for everything. And we'll also have the components that wrapped into the dependency injection services that the client and server applications can consume and implement, I would say, override to supply the data, that the actual data through this infrastructure. And all of that will be, but the idea is that it's a messaging platform between the client server and down through the web API with persistent storage with the SQL database. And that is the messaging pipeline that will be defined within this component. All right, so above this layer, we'll have another layer of abstraction, but again, with every layer that we go, we become less and less abstract, and we become more and more specialized towards the actual requirements in our web application. And in this layer, we will have three major parts. Again, all of this is not set in stone. We might rearrange certain things, even shift certain things back and forth, get rid of some, add something. But these are the main things that I'm thinking of. That is the JParts component, which is again an abstraction library where we consume the services from the JSON, which is communicating with the Pixie.js, and in JParts actually defines the specific models for the game itself, as well as the view components that will be using those models, that will be used to render those models on the screen, and all of those will be calling into the JSON to do the actual rendering. So, for example, in Pixie.js, you have a class or a structure class you could call that is, say, a sprite, which is an abstraction to render a primitive on the GPU with the texture. Pretty much, there's more to it, but let's say that. So you have a primitive or two primitives, two triangles organized together, making a rectangle, making a rectangular area, which can be mapped to have a graphics data like texture, like image texture on it, and then drawn on rendered by the GPU on the screen, right? On your screen buffer, whatever. The WebGL is very low level in that sense. You have to actually work with primitives and UV coordinates, texture, all of that stuff is very low level. So Pixie.js is an abstraction above that, where it says, okay, now we take all of this and make it into a sprite. And sprite is an abstraction. There's no such thing as sprite. The sprite is just kind of like it's like color red. There's no color red. There is a electromagnetic wave or a certain frequency that we define as color red. So the same thing, sprite is an image that is under the hood represented by these two primitives rendered by the GPU with the texture. But we don't need to go that low with Pixie.js. We just work with sprites that has all the properties, higher level properties like position and rotation and scale, matrix transformations and the texture and the transparency. All of that stuff is abstracted by Pixie.js really nicely, so we don't have to deal with WebGL. Now, for us though, we don't want just a sprite. We want some kind of a highlight. Say, for example, if I have a character in a game like that has certain things attached to it. Yes, it is not just a sprite. It's actually a collection of sprites. Organized in a certain way, behave in a certain way, and react to user input in a certain way. So instead of coding it directly with Pixie.js, we will have these layers of abstraction that allow us to make it even to make it even easier to then scale up and consume later in our applications. So again, if we have a sprite, we could have things like, say, above sprites. We could have things like a particle system, for example, which is a WASM component that renders multiple sprites with a given logical pattern that is encoded within the particle system component, which is higher in level than just the sprite, right? And things with animations, for example, you can have a sprite, but then if you want to animate it, you have to kind of write the code yourself with Pixie.js. The JScene has a certain infrastructure to make sprite animatable without actually writing much code. And then once we have all of these less abstract, more specialized components, then in the JParts library, we can then say take and assemble a character, and a character would be kind of a tree of components from JScene, where you would have the sprites, where you could have the particle systems, where you could have all your animations coded and everything abstracted into a character class, like you have a J character class or whatever, and that is then much easier to consume later in your actual application. And this way, the architecture kind of separates the different abstraction levels into different layers, which makes it much easier to scale or change things later on if everything was like written just in one layer. Anyway, we have the JParts, which is pretty much the abstraction of the entire game. We have the API defined in that layer as well, which sits on top of the ASP.NET Web API with controllers leveraging all of the JNetwork services and classes. And we have the game server component that is managing, that has the logic to manage the state of the game pretty much for multiple games, for multiple users at a time, and all connected again to the network using the messaging pipeline to store the data on the SQL server as well as populate the data locally in the SQLite databases. All right, and finally, we get to the actual web application. So this is the application that the users actually will be interacting with. Oh, not just users, because it's also the server part of it. Anyway, and but we will be talking about the web application. Like it's pretty much a website, an active website, you would say, a dynamic website built in Blazor. And two modes that we will be using most is the SSR, stands for server-side rendering, where the website is, it looks like it is client rendered. It's really nice technology with Blazor that uses WebSockets to make like these short, quick requests to the web server in real time, performing actions on the front, on the client side, looking as if it's it's rendered by JavaScript, but in fact it is these micro calls to through WebSockets to the server. It's a really nice way to actually make your website dynamic. I find it the most natural way to code interactive content at this time. So we will have the wrapper website, mostly built with SSR and with embedded identity management, which is the user accounts. The same thing as .NET, ASP.NET out of the box provides this identity framework, allows you to create, manage user accounts with all of the scaffolding, and everything is in there. It saves a lot of time. The way it's set up, and has the ability to plug in external identity providers like, whatever, Google, Discord, whatever you want. And I don't know what else is going to be on that website because, frankly, I haven't thought about that much about the content of the website itself, as I've been focusing on the game first. So the website, at least the first version, will probably be very rudimentary. Not much in it, just the basic user interface. Maybe it's just going to be one page. I don't know. We'll see. But the main component is the game screen itself, and that is going to be rendered in WebAssembly, like compiled to WebAssembly, rendered by the WebGL through Pixie.js and everything else. And the two components, like the two, I didn't say components, the two methods. Of course, there's one thing with Blazor, Wasm, and SSR. They don't really play that well together, so we'll have to be a little bit creative about how we kind of combine them. And there are some ways to do it. There are ways to work with it. It's not completely hopeless, but I intend to do so, to have some compromises in that regard as well. And that's about it. That's the plan for now. And hopefully I didn't bore you too much. If you're still here, let's go into Visual Studio and start writing code. All right, here we are in our Visual Studio 2022. So let's create a solution for our project. First, an empty solution. Go here, create new project, blank solution. Next, and let's give it a name. I'm gonna call it Jerboa Wars project for now. And I'm gonna hit create. We have our empty solution, and now we can start populating the solution with our parts of the projects. And we'll go by layers as defined in our architecture. So let's add a few class libraries, starting with the lowest one, add new project. And we can say, actually, the first one, class library that we're going to have is going to be, actually, because the JScene is going to have the eraser component in it, so we can just create a eraser class library immediately for JScene. I have it in my recent projects here. If not, you can find it in all of this, a search here. So let's create a eraser class library, and all it does, it actually just adds some dependencies for the eraser components. Let's call it JScene. Next, and it is .NET 9, the last one. We don't need any pages or views, or we are not messing with the .NET Aspire for this project for now. We might add it later if we need to. Say create. So this will generate the project for us with dependencies on the .NET Core components, the web, for the web, and we'll have a couple of example stuff here. This is the just an example component and JavaScript interop. We don't actually need any of that. I can just get rid of it immediately. I'm gonna delete it. Yes, but we can start adding things later. But for now, let's add another project for the second layer, which is the J parts. Let's add another new project. It's going to be a normal class library. Say next. And we're going to call it J parts. Next. And .NET 9. Create. And there's a sample class file there we don't need. Let's just get rid of it immediately. And the next part is going to be I'm going to skip the network for now. We're just going to build things a little bit vertically as well. We don't need to build every layer completely before moving into the next layer. Everything will be kind of dynamic. So when we get to the network, I will add that project, that layer with the API and all of that stuff. For now, what I'm going to do, I'm just going to add another project for the web application itself, the front end. And this is what we start with, something we can run immediately. So add a new project, and that is going to be an ASP.NET Core web, not the web API. What we want is Blazor web app. What we want is a Blazor web app. It's also right here. We're gonna pick a few. Let's name it JGame. Next. And we're going to pick a few options. We will be using authentication later, so I'm going to include it immediately here. I'll leave the configure for the HTTPS. We need the, we'll leave it on auto server and WebAssembly. So this, what this will do is going to generate two projects for us actually. One the server side and one the WASM client side. We're going to be needing both. And we don't actually need any sample pages, and we don't need the Aspire for now. So let's create this project. And here we are. And as you can see, we have two projects, one the server side, and then this one is JGame client side. And the server side has a dependency on the client side, automatically declared here. So whatever server-side components we built, we put in the server project, and whatever client-side WASM components we built, including our the game itself, I'm going to put it in here in the client, in the WASM client. All right. So what do we have? What can we do right now? I'm gonna. It's all the account stuff. So this video is just the setup. We're not going to do any real coding, just a little bit setting up the infrastructure. We'll be using dependency injection for these projects to call different components from one project to another. Very versatile and scalable pattern. That's what we're going to set up right away. So in our layers, we have the JScene is at the bottom, JParts is in the middle, and JGame at the top. That means the dependency goes from top to bottom. We have the JParts depend on JScene, and JGame depending on JParts. So I'm going to add a project reference for the JParts where we have the JScene referenced, and for the game and the client, actually both of them. I'm not sure if the server will need that because the scene and the parts is only the client side. So let's put the dependency for the client side project only, the WebAssembly. So let's see. We have the add project reference, and we're just going to reference JParts. All right. Now, next, what we're going to do is we're going to add a couple of static classes to define the infrastructure for our dependency injection. Starting with the JScene, just add, first of all, let's add a folder here, and we're going to call it dependency injection. All right, and let's call it services. And we're going to add a class that we are going to call dependency injection. Like this. So whatever services we have, the top level services, we can be putting in this folder for the JScene and then exposing them to the dependents through dependency injection pattern. And for this, the setup is pretty simple. So here in this static class, we are going to add a static method, extension method actually, for the iService collection interface that we will be using to add our custom services into the service model. So let's do it with a simple method. I'm just going to say public statics. Actually, it is getting us already there, halfway through where we need to be. We're just going to call the method add JScene like this. And the method correctly suggested by Visual Studio here is going to be our service collection instance. And here we're going to be adding services to do. And the method is just going to return the same collection. Sorry, this is a static method, services. That's right. All right. So now we can use this in our program.cs file, where we have the service builder methods called here. We can just add our service here as well. I can just say builder services add JScene like this, right? And using the JScene services, and now we have this service that whatever services we declare in our JScene library will be injected here in the client with just this extension on the Fusion. And we're going to do the same thing for the JParts library. I'm going to add a class, a folder first. I'll call it services. And the same thing, I can just copy paste actually the whole thing, except for the namespace. Now, in services, I'm going to create a class, call it dependency injection, and copy paste this thing here. And now we have the JParts services and we have the JScene services. Whatever classes that we will be building, say in JParts, and if these classes need access to functionality or resource from the JScene project, JScene library, we can easily just put that class declaration, or the declaration for that class in the constructor of our JParts class, and that will be automatically injected because it is declared here in the builder. All right, add it in the builder, I should say. So let's add a JParts here as well. And let's add the using, did I call it right? JParts service 8. Oh, because I did not rename it here. JParts. And now we should be okay. Yep. All compiles. And we have our basic setup for what we need. So in the next video, what we're gonna do is gonna add the dependencies for all of those very nice open source libraries that I was talking about, like Pixie.js and the SpawnDevs wrapper. And we'll start building the JavaScript layer, the JavaScript interop layer, I would say, between the JScene and build out the JScene architecture. That's the next logical step, I would say. But in this video, I'm going to end with pushing this, making a new repository for this solution, the whole thing, and pushing all of these, committing all of these files that we've just created to that repository. That will be our starting point. And of course, the link to the repository is in the description. Visual Studio has a really nice interface for source control. I can add the entire solution with the default templates and everything could be easily created, added to the repository can be created, the whole solution is added and committed, and everything is done all in this interface. We don't really need anything else. So I can say create a Git repository here, and I'm going to push it to my GitHub account. And as you can see, it already pre-populated most of the stuff that we need. I'm not even going to bother with the description or anything at this point. We can change it anytime. So the visibility, I'm going to say set to public. And that's pretty much all we need. I guess I could add the README file now. Let's push this to GitHub. We have our project URL, and let's click the button. It is going to create the repository and push the file. So the Git repository has been created for you. All right, and here we are in our GitHub repo. As you can see, the code is here. The project has been created. The files have been pushed. All right. So all the code that I'll be writing, that we'll be writing together, will be pushed here. And I'll see you guys next time. Cheers.